Welcome to Study Loop.
Hi. So in this question is given a cable, the two supports of which are not on the same level. So this is the cable. This is the lowest point C, and the supports are A and B. Okay, and the distance from A to the lowest point. This distance is A, and the distance from the height of A to B, this distance is 2.25 meters. Okay, and this distance is 9 meters, and this distance is 6 meters. Okay, and a uniformly distributed load is acting on the cable. A uniformly distributed load is acting on the cable, and and the mass per unit length of the cable is 60 kilograms per meter. So this is the equation. So in the first part, we have to find this distance A, the vertical distance A. In the second part, we'll find the length of the cable S, and in the third part, we'll find the component of the reactions at A, point A. Okay. Okay. So let's solve the first part. Okay. So we know that the the supports are not on the same level, so we have to apply the equation of the parabola for this cable for the two parts of the cable, one for AC and one another for BC. So let the tension in the lowest point of the cable be denoted by T naught. Okay. Okay. So the height of the cable, if we apply the parabola formula to this part of the cable, the height of the cable is A, Y, that is the height Y, is equal to weight per unit length, that is W, small w, and X is this distance, that is X square is 9 square divided by, so the formula is Y is equal to W X square divided by 2 T naught. Divided by 2 T naught. Okay. Okay. So W in this case, W in our case is the weight per unit length. For this part of the cable, it is 60 kilogram per meters times 9.81 meter per second square, the relation to the gravity, and this is the Newton per meter. Yes, this is the weight per unit length in Newton per meter. So we will put this value of W in this equation. So our A becomes 60 times 9.81 times 9 square divided by 2t naught. Okay, okay. And let's write the same equation for the other cable, for the other part of the cable, for for this part. For this part, this height would be equal to a minus 2.25, as you can see. So this is a, this is 2.5, this is a minus 2.25. Okay, so let's write the other equation. So this, if, let's write it here. So a minus 2.25 is equal to weight per unit length will be the same, the W, and that is 60 into 9.81 W x square, and x this time is this horizontal distance, this distance. So it is 6 square, 6 square over 2t naught. So this is our second equation. So so from one of these equations, let's say from the first equation, we will get the T naught in terms of A. So T naught is 60 into 9.81 times 9 square divided by 2A. So and we'll substitute this value of T naught in the second equation. And the second equation becomes A minus 2.25 is equal to 60 into 9.81 times 6 square divided by twice of, put this value of T naught, 60 into 9.81 times 9 square to 2a. So this is cancelled, and this, if we solve for this for a, then it is a minus 2.25 is equal to, this 2 is also cancelled, 36a divided by 81. So 81a minus 36a should be equal to 2.25. What is 81 minus 36? 45. Yes. So our, this becomes 45a is equal to 2.25, and a is equal to, I think we have done something wrong here. So 2.2, this should be 2.25 times 81, because this 81 is multiplied here. Yes. So it is 81 times 2.25 divided by 45. Okay. Yes. So this a comes to be equal to 4.05 meters. This is the solution to part A of the problem. So let's solve part B. In the part B, we have to calculate the length of the cable. So the length of the cable would be equal to this length plus this length that we will calculate separately. This length is L1, this length is L2. The net length S would be equal to L1 plus L2. Okay. So we know that we have a formula for calculating the length of the cable. That is So formula for the length is, for L1, the first part of the cable, the the formula would be x times 1 plus 2 over 3 and y over x whole square minus 2 over 5 y by x times 4, and this goes on, but we'll just consider the first three terms of this formula. So L1 becomes, so x in this case, in the first part of the cable, the our x is 9, and the second part x is 6. We're considering the first part right now for L1. So x is 9 times 1 plus 2 over 3, and our y for the first case is equal to the value of a that we calculated in the first part, that's 4.05. That's 4.05 divided by 9 square minus 2 by 5. 4.05 divided by 9 to the power 4. Let's consider only these terms. So if we solve for this, L1 would come out to be equal to 10.067 meters. Similarly, we get L2, and the equation for L2 would be, because x would be 6 in that case, so 6 times 1 plus 2 over 3 times y is the elevation of the distance, the vertical distance between B and C, this elevation, and that would be equal to A minus 2.25. That is equal to 1.8 meters. Okay, so this is y is 1.8 times x is 6 square minus 2 over 5, 1.8 by 6 to the power 4, and this L2 comes out to be 6.36 meters. So our complete length S would be equal to L1 plus L2, and S would come out to be 16.41 meters. So this is the equation, this is the solution of the second part, part B. So for the third part, part C, we need to get the reactions at A. So if this is the cable A, C, B, the reactions would be AX and AY. So we are assuming them in these directions. Okay. So for this, to get this, we will draw the two free body diagrams. The first one of the free body diagram of AC. Okay. So let's denote the, let's take AY and AX in these directions. That would be easier for calculation. AY, AX, and we know that a weight is acting on it in middle, that is equal to length. The weight per unit length we know is 60 into 9.81 Newton per meters. So the complete weight acting on this cable would be equal to, the length is, this is weight per unit x. So x here is 9. So this cap, capital W, or the weight acting, this is capital W, is 60 times 9.81 times 9, this much newtons. And this comes out to be, okay, just a second. So this comes out to be around 5 297.4 newtons, or approximately equal to 5300 newtons. So in the field point diagram, this weight is acting equal to 5300 newton, and that force of tension is also acting here equal to T naught. That is the tension in the cable, the horizontal tension at the lowest point. So if we write equations of equilibrium for this part, for the vertical part, as only two forces are there, so Ay would it could be equal to the capital W. So Ay here would become equal to 5300 newtons in the upper direction. So this is one answer. Now we have to get Ax. From this we can see that Ax is equal to T naught. But we don't know T naught. So for getting T naught we will have to write one more equation. Okay. So let me write that other equation. For that we will take the free body diagram of the part CB of the cable, the other part of the cable. CB. So similarly, B would have reactions Bx and By, and this distance, as we know, is A minus 2.25, or this is 1.8 meters. And the reaction at this point is T naught, the reaction, horizontal reaction in the cable. And the weight is also acting here downwards. Weight, capital W2, we can say. Okay. And this capital W2 would be equal to small w, that is 60 into 9.81 times 6 newtons. If we write the equations of the rotational equilibrium about C, if we make the sum of moments about C to be equal to 0, then if we write the equations, so if we write the equations, then this distance is half of 6, so 3 times W2 and 3 times W2 times W2 should be equal to 3 times W2 plus By times this distance, that is 6. By times 6 should be equal to bx times this r, because torque is r cross f, and we are taking the sum of the moments. Bx times 1.8. Okay, I think that's it. And we know capital W2 here, so substitute this value here, and this is one of the equations. And the second equation would be the horizontal equilibrium equation, summation fx equal to 0. That will make bx equal to T naught and bx equal to T naught. And from here we get the relation between by and bx. Let's solve it. Bx equal to T naught and okay. You can solve it on your own. So in the end, the T naught would be equal to bx, and we know that here ax was also equal to T naught. So from these equations, the T naught comes out to be 5890 newtons, and as we know that ax was equal to t naught in the direction that for the ax that we chose towards the left. So ax is 5890 newton in this direction. So this is the second second solution to this to the part C of the problem. Okay, I think that's it. Thank you very much for following.